Hello again. Can we start? We already met at the keynote where I was talking about the cloud-native architectures, and what I've mentioned there was that the key ingredient of the cloud-native are microservices. And in this presentation, we would like to show you a simple demo how to develop microservices with JavaEE, and how to actually pack them, deploy them to a Docker container, and execute them. Now, I would not repeat the things that I have already mentioned. The fact is that microservices are a hot topic in Java ecosystem, and it seems that this year and next year, a major transition from classical application servers towards the serverless Java and microservices will happen. Now, without saying too many words about the theory of microservices, let us have a practical look at an example. And what we will do here, we will build an oversimplified web store. And if we would develop such a web store in a classical JEE manner, this would basically be an application which would consist of, in this example, 3 services: the catalog, cart and payment, and delivery. We would use maybe a queue behind, a database, a front end, and we would pack the whole application as a single enterprise archive, or maybe it would consist of 1 or more web archives and several enterprise archives, and we would pack all this together into a single deployable unit, which we would put on an app server. So this is the current approach how we develop JEE applications. This is well known. It is easy to manage. We understand it, we are familiar with it, we know how to scale it. If we would like to scale it, we need to set up a cluster of app servers, and what we can actually do, we can scale the application as a whole, right? But for each and every web store, I would argue that there are certain components which are used more often than the other components. What do you think? What would you think if I would say that the catalog and the browsing the catalog in a web store would be a much more often used functionality than the payment and delivery, for example? And now, in a classical monolithic applications, we call such applications monolithic because we pack them together in a single deployable unit in a single ER. Such monolithic applications have certain limitations. Scaling is one of those limitations. So if we have a monolithic application, we can scale it as a whole. This might make sense, but in most cases, this is not the most efficient way how to scale an application. Let's see how we would do it in a microservice way. In a microservice way, this application would break up into 3 different services and a front end. And the major difference would be that we would pack all those different parts, so the 3 services and the front end, we would pack them separately. So the catalog would be one separate unit for deployment, not only a logical service within the application, but we would actually pack it and deploy it separately. The same holds true for cart and payment, for delivery, and also for the front end, particularly if it's the server-side front end. If it's the client-side web development, then things are a little bit different. Now, when we think about microservices in JavaEE, there is then one obvious question: what to do with the app server? And this is why I already mentioned this serverless Java approach, where there are basically 2 ways how to approach this. some frameworks have emerged which allow you to pack the JEE artifacts, for example, REST services, in standalone jars. This is called the fed jar approach. So instead of creating an ER and which would require an app server, you pack the whole REST service into a standalone jar, which already contains all the parts of the execution environment, of the JEE execution environment, which are required. Not all of them, just those which are required. So you can basically use Java Standard Edition runtime, so Java runtime environment, to execute it. No application server required. This is convenient because this way we can get lightweight microservices which do not require some heavyweight infrastructure, and we can pack those microservices into containers, into Docker containers, and get this efficient lightweight approach which I was discussing previously on the cloud native presentation. The other approach are app servers, particularly JBoss with the Wildfly Swarm has approached the modularization of the app server. So Wildfly Swarm is actually a modular app server which allows you to configure only those APIs, JEE APIs, which you actually require. So for example, if you would have a REST service which would require JAX RS, CDI, and JPA, then you would simply select those three technologies and get a really lightweight app server environment. What we will show you here is how to use the KumuluzEE framework to develop those microservices, and just in between, once you pack the application in a microservice way, you get all those benefits. I do not want to repeat everything, but scaling is one of them. You can develop this in parallel, so each microservice can be developed by its own team without interdependencies. You are free of using different versions of technologies, even different programming languages, and so on and so on. So it really brings some important advantages. And this is why we understand that it is actually a perfect building block for new modern cloud-native Java applications. And this is very related to this discussion about Java EE, which might not be which might not be so interesting anymore, because Java EE, these heavyweight application servers, they really do not fit very well into the cloud architecture. And as far as we believe, this is actually the way the Java will go in the next few years. Now, what we would like to show you here is a framework that is an open source framework, KumuluzEE. It is the first framework for developing microservices using standard Java EE APIs. So if you don't want to go into the Spring direction, if you would like to use the standard Java EE APIs, KumuluzEE allows you to pack JEE applications such as REST services, SOAP services, whatever, into microservices using the fed jar approach. It is an open source framework which was awarded the Java Duke's Choice Award last year. And actually Tilen is the lead developer and the architect of the framework, and he will show you some hands-on demos how to develop microservices using KumuluzEE. Tilen, please.
Okay, all right. So let's continue on with the KumuluzEE framework itself. As Matjaž mentioned, it is using the standard Java EE APIs. So if you or your team or your company is already heavily invested in the Java EE ecosystem, this is kind of a perfect fit for you, where you can still use your existing knowledge, all of your existing resources, and still be able to develop modern cloud native applications without completely changing everything about your development process. One of the main benefits that we talked about is its size. Application servers can become quite big. They are smaller ones, like Wildfly is fairly optimized, but then you get into the bigger space of IBM and WebLogics, which can become quite big. For a simple application, most of the time we don't need everything in it. For the most part, for instance, if you only need a servlet implementation, which is basically HTTP plus some other stuff on it, it can the jar can be as low as 1.5 megabytes plus, of course, your code with it. If you want to add JIX RS, so you have REST services, the implementation goes to 5 megabytes. And if, let's say, you want a more modern stack, which is a typical stack that you would use with JPA, CDI, beam validation, and JSON-P, it would be about 15 megabytes plus your own code. Now, so you can see that you can severely reduce the size of your code by just using what you need. Most of the time in the modern application, these are the technologies you will use, and others you will only include if you need them, but not necessarily, as is in most cases. How does the framework work? Well, we told that it was completely modular and it is completely dependency-driven. You select what you want using Maven dependencies. For instance, here we selected that we wanted a servlet implementation, in this case Jetty, and we wanted a JIXRS implementation, in this case Jersey. You pick what you want, and then you use your existing knowledge of of Java EE to write the applications that you know how to write from before, and can use it all the same. We will show a demo later to see that to create an application which will look exactly the same as you would make it today or maybe yesterday. One of the other benefits is that you can see that in the dependencies, it's also specified the implementation. The framework supports different implementations for different components. For instance, we can use different JPI implementations if, for instance, Eclipse Link is not, we don't like something about Eclipse Link, or Hibernate has one feature that we like, we can swap them however we like. And it's all compatible between the subs. The framework takes care of that. How do you run it? Well, basically, you build it with Maven like you build any application you make with Maven, any kind, and then you can either run it directly. Framework comes in a main class that you run, and it will configure everything for you, or you can create a jar and then run that. Both options are available. And of course, since it runs in the Java SE environment, it runs like any other Java app that you ever create, console, desktop, whatever. It has first-class support for Docker containers, and with that, you have support basically for every cloud environment there is, as well as most of the popular orchestration framework for containers, Kubernetes, Mesos, CoreOS, if you wish, OpenShift, and so on. You have a lot of this, and you can use it on all of them. You are not limited by any way. Okay, so let's proceed to a demo. Right. Okay, so here I will enlarge this a little bit. Here I have 3 microservices as an example. I will swipe between them like this. So 1, 2, 3. And basically 2 of them are standard REST APIs, while one of them is a microservices with a JSF UI that uses those microservices, just to show you an example of that you can still use all the other technologies that you know. I will also explain more. So if you look at this one, this one, we have a microservice that handles, for instance, our accounts in our user application. If you take a look at the application, I won't spend too much time on it. It's a normal application with JPI. So for JPA, for instance, classes, I will enlarge this a little bit. Here we go. With normal JPI annotations, and then we are using this with our normal JIXRS APIs to expose this via REST services. We have a few resources that we expose, and then we have a standard CRUD app, create, read, update, and delete. You may see that everything is red now, because in this concrete project, we haven't added yet the dependencies needed. Since we haven't added anything yet, everything will be red because we don't have any APIs included. I wanted to show you how easy it is to take an app that you may already have or write a new one and then just run it. Okay, so let's go to our Maven example. Of course, I'm sure you are familiar with this, and let's add our dependencies here. I will add them this. So basically, you have to add a KumuluzEE dependency, and then you add as much of them as you need. The first one you need to add is a core dependency. I already have a version here specified, so I don't need to repeat it. The first one you need to add is a core. This contains the core of the library, all the necessary stuff for it to be working. This just by itself doesn't do anything, of course. You need to start adding, let's say, building blocks, Lego blocks that you put together to create the stack that your application needs. So I will mostly copy this, since it's a lot of manual writing. And let's first add, what do we need first? Well, first we need a HTTP server or a servlet implementation. So we can add a servlet implementation. Let's in this case add Jetty. What else did we say that we will use? We mentioned JPA for our database access, so let's add JPA for our database access. In this case, I can add either Eclipse link, or I can add also Hibernate. Can choose between either of them. You can either use the Eclipse link implementation or Hibernate. In this concrete example, I used the Eclipse link to show the various components you can mix between itself. Then we mentioned REST services, so we will need GIX RS implementations. Let's take a look at this. And then we will use the Jersey implementation. We could have used, for instance, the RESTease implementations. But here you can see we mix a little bit of JBoss's, Red Hat's technologies with a little bit of Oracle's technologies, and it still works, basically. And then we will also add a CDI implementation so we can have various injects and request scopes and scopes and so on in our app. We don't need to, but just for the simplicity in this case, we will add it. It comes very handy in a lot of cases. We will use the Weld implementation, which is the reference implementation for CDI. Okay, and this is basically it. If we go back to our code now, we will see, let's go to a different class, we'll see all our errors disappear. We added all the dependencies, it included all the APIs, and we can now run it. So how do we run it? Well, we mentioned don't need any app server. It's a simple Java EE app, so we run it as a normal Java EE implication. In IntelliJ, this is done like this. I will just name it something. We'll run it as a single instance, and then all I have to provide is the main class of the framework. Here we go. And also we can run it. But before I run it, I want to mention one more thing. We will also be using service discovery to register these services in a service discovery, so our UI service will be able to use them to mention the URL. So how is this done? Let's just go to the code a little bit quickly. On startup, basically we will be using for our service discovery, we will be using ECTD, which is a popular service discovery framework that we can use. It is used in Kubernetes, in CoreOS, and a few other big projects. Other alternatives are, for instance, Zookeeper or Consul by HashiCorp. We will use, in this case, ECTD, just for example. What we will do is, when we will initialize the service, we will put the URL of our service into our service discovery for others to discover. And when we stop the service, we will delete it, so it's no longer available. On top of that, we will also use the same service discovery to handle our configuration of our microservice. In this case, we will be fetching a configuration from our service discovery and then apply it to our application. Not only that, we will also watch it, or in this case, subscribe to it. So if at any point it changes, it will automatically update the app with the new configuration without it restarting, which you would need to do if you would use environment variables. Okay. We see here that we've passed a few environment variables still. For instance, what will be the ID of the service, what will be the URI of the service, what's the ECTD URI of the service, and so on. So we need to add that, and then we can run it. So I'll go back to my configuration, add a few environment variables. I have them prepared here, so I won't need to copy them. Basically, I need to add the service ID, which will be used in the discoveries. In this case, it's just accounts and 01. For instance, this would usually come from your environment, for instance, Kubernetes or something like this. Then we will use the base URI of it. And I need to provide a etcd URI for where it exists. Here we go. Okay, apply, and then I just simply run it like any other applications. It'll compile it, it'll run it. You can see here, it runs in the console. That's it. It took maybe 1 second to run, and it's working. So we can try it out. I will open a browser. Basically, we'll go here, and here we have a REST endpoint for custom. Oh, I wrote it wrong. Here we go. We run it right now. So let's see if it's working. Okay, here we go. We already received, I have a database running behind it, connects to the database, already have, and received a REST entry from Tundam. So we see it is indeed working. Let's take a look at the service discovery a little bit more. Before we do that, let's first turn on all the other microservices, so we can see I already have all the other prepared, so we don't need to waste time on this. I will run the different microservice that handles, it's basically like a sample ticketing system. It handles tickets and such. And then I will add the UI, which will display all of this. All three of them are JavaEE microservices, 2 are REST services, and 1 is a JSF service. Okay, before we go on, I would like to show you what this means for our service discovery. I will show you the terminal, and then I will show what's inside our service discovery framework, etcd in this case. So we can use, I will say, we can use the tool etcd to browse our service discovery memory. So in this case, we will check our account, for instance, our account app, which stores all of its configuration under this namespace. You can configure the namespace however you want. In this case, I use this. We can, it's account, sorry. Accounts, and then inside we see that we have 2 folders, a services and a config folder. If we go into the services folder, we will see that here is defined our account 01 web service, and if we see what's inside, we can see that it's our URL that we previously put in environment variable. So other servers will be able to discover this and then use it to make our REST call. Other stuff inside is, for instance, the config. Okay, it's a directory. We see here that we have other config variables. This one is particularly interesting. It specifies whether our apps is in maintenance mode or not. In this case, it's set to false. Let's see if this is true. It's set to false. But if we want to put our app in maintenance mode, all we have to do basically is just set it to true. Let's go back to our service. Now that I refresh it, you see suddenly the app, the same REST endpoint doesn't work anymore, but just returns that it's in a status maintenance mode. So you see that simply by using a centralized location for our config files with an appropriate tool, I can dynamically reconfigure all my services on with my application. I didn't need to restart the application. I didn't need to do anything. I just changed the value in etcd, and it automatically propagated to every service, and it automatically picked it up. If I put it back on, let's say I return it to false, refresh works immediately. You see, it's instant basically, right? All the updates are practically instant in this case. Okay, let's see if our other REST service came online. It's on a different port in this case. It's tickets. Let's try it. Okay, in this case it works as well. Let's for the finish, let's just take a look at our UI application. Here we have how it works. Basically what we do, our method to get all the customers is basically a REST client that receives the URL from our service discovery. In this case, we just call a function that discover service and we pass it the ID, and it goes look into the service discovery to get the URL. No hard-coded URLs, not even in our environment variables, completely modular, and we can change it however we like. And then we just call it and get it. Now, if we want to look how the UI looks, I will open it right now to see if it works. And just to show you again, this is a normal. This one is a JSF web page that is running inside a microservice, not on a web app. And we can see, it works. We have an app that calls the REST service and displays the data we saw before as a JSON format. Another thing I wanted to show you, this is a standard JSF web page. For instance, here we are using a UI repeat element that you all know. We could use data table and so on. But the other one that shows all our tickets, if I switch to it, is not, in fact, a JSF application. But here I'm using, in this case, I'm using a JavaScript framework, in this case Vue.js, to render dynamically on the client my app. Here you can see a little bit with JavaScript. So here I want to show you that how you can use with your existing JSF. You can use both the standard JSF as well as you can use a modern JavaScript application framework to develop your application side by side. One page is like this, one page is like this. So you can gradually migrate to a more modern app. In this case, we are using a little bit of a, let's say, trick. We are getting the URL from our service discovery and put it in the JavaScript so we can here make when Vue.js is mounted, it fetches it fetches the URLs and tickets and basically displays it. And here we have the directive for displaying it. Why I'm showing this framework? It's very, you can see it's very simple to integrate without an entire framework. For instance, like Angular 2 or React or some other. Okay, so this was just for a demo. I hope it was interesting. You can see, I hope you saw that how you can make several microservices and then connect them with the service discovery tool and automatically update them with configurations and such. I could also show you, but I think we're a little bit lack of time, to how to make a Docker container. Basically, it's very easy. I have a Docker file that just is a normal Java Docker file you can see from the OpenJDK project and just puts the app inside and runs it. Sets a few environment variables, but otherwise it just runs it. If I think I can build it very quickly. I need to go to, let's go to the, let's say accounts. I will go to the, sorry, the tickets, and then I can build it. It'll take maybe a second.
So Tilen,
yeah.
And while the Docker container is building, let me just summarize, because we are running out of time, I believe. Let's just summarize what we tried to show. Actually, we showed how to develop microservices using standard JavaEE APIs. Tilen showed basically 2 REST services with JPA, CDI, and some other technologies behind. Tilen also showed how to use the front end. Now, he showed a mix of Java server faces and HTML5 JavaScript. Well, we showed this because some of you might have some existing Java applications using JSF or some other Java server pages, servlets, whatever technology, and would like to gradually migrate to HTML5 and JavaScript. Of course, we could also develop the whole front end in JavaScript. This would be basically no problem. Now, what Tilen showed just now is how to pack those microservices into Docker containers, something I was talking about. Now, but if we just use microservices as they are, the problem is that we depend directly on the URL of a microservice. And if we would like to scale the services and if we would like to deploy them freely, it would be very inconvenient if our front end would depend on the URL of a microservice directly. This means that we would actually code the URL within the front end or something like that. This is why Tilen showed you very quickly how to use service discovery. This is a complex topic. We could talk for hours on this, but just to give you an idea. So instead of going directly on a REST URL, we go on a service discovery and then get the URL of an instance of a REST microservice dynamically. This allows us to have much more freedom for the deployment, but also to do load balancing and elasticity and horizontal scaling and so on. So if this application would get under heavy load, we could actually instantiate several the same instances of the microservice horizontally and then route the clients to different URLs of those instances. And then finally, when we have such distributed microservices in Docker containers or executed from the command line, doesn't matter, we need to solve the problem of configuration. Yeah? In JEE app server, configuration is centrally stored on the app server. For microservices, we need a solution for that. So the easy way are environment variables. But environment variables have the problem that if you change them, you need to restart everything, and it's also difficult to change them on all different virtual machines, for example, Docker containers. Yeah? That's why the service discovery can also be used for configuration. And Tilen showed you that if you change the configuration, the response is instant. Yeah? And this, if you recall what I was talking about on the keynote, in the microservice environment, you need to allow the different versions of the same microservice run hand in hand. Then you need those configurations. For example, this maintenance and non-maintenance mode, this is a typical use case because you deploy a new version, it doesn't work, you put it into the maintenance mode, all the clients will fall back to the previous version and so on. This is how it goes dynamically. Yeah? And finally, let me just spend 2 or 3 sentences about gradual migration. What is possible with microservices and also with the KumuluzEE framework, which is, by the way, open source, free of charge. You can try it. Yeah? You can gradually migrate to microservices. And the usual scenario is if you have a monolithic JEE application, what you can do, you can develop some new functionalities when you need to extend the app, add some features. You can develop those new features as a microservice which runs side by side with your existing JEE application. So no need to put, I don't know, a month or 2 months effort into breaking down the old app. You can leave the old app on the app server and add new functionalities and microservices and have everything running side by side, which is quite important. That's all from our side. Some questions?
Now that we have split application server into many small components, what would be the benefit of actually running it instead of just picking up the components as they are? You show demoed how you picked your version of Jersey distributions. Why not pick Jersey as it is, directly from Maven? What value does it give?
There are actually several implementations.
Why pick your Maven package? To put it bluntly, why include your Maven package instead of directly Jersey?
Because while you can try and do all of this yourself, some components play nice and some components don't play nice. So the framework isn't just just adding other dependencies together. It also has some other stuff that makes other stuff work together, like CDI with JXRS, with EGB, with GTA. All of this, I didn't show all of it, but the basic stuff is maybe JIX.rs will work out of the box on Jetty, but to integrate all the other components that you would like, if you will just add them together as dependencies, they will not work. You need to manually handle it. That's why they are application servers, because they also do this on their own. But of course they have all of it, so this is also what this framework helps you to do. So you don't have to you don't have to worry about how these things will fit together. Do they work? How will they work together, and so on. I know, for example, to integrate SOAP services and CDI, it's already quite a problem. It doesn't work by itself out of the box. So this is what the framework brings you. It simplifies adding different components together without you have to worrying about the internal buildings of each framework and how they interact with each other. Basically similar to what an app service does, except it does it in a more microservice-oriented way. That's basically the differential, the volume, the value added stuff for the framework.
Thank you so much. We have to continue with our next lecture, so if you have any additional questions, just try to catch Matjaž and Tilen, and they will explain to everything. Thank you so much.
Okay, thank you.